English for the paper of international student in the future, so that everyone can try to understand lah. Not only Malaysian, but everyone can understand this. Okay, so we this topic is about critical frequency of helical spring. Okay, so uh, what do you mean by critical frequency? Okay, it's a wave is created by disturbance at one end of swimming pool. This wave will travel along the length of a pool and reflected back at the far end. Okay, continue its backward motion until it is finally dammed out. Okay, you just can imagine if you put wave on the. Okay, I try to make okay. Okay, let us see some okay, if you put inside the Google, I type the word ripple effect. Okay, this is what the means by ripple effect lah. You can imagine and a swimming pool or a flat surface or of a lake, um, no no disturbances on the lake, and then you throw a stone inside the lake or throw a stone inside the swimming pool, it will become a disturbance. Okay, it will become the ripple, the wave will go travel back and forth until it become normal again. This is what it means by critical frequency lah. It means by frequency. Okay, if you type about the frequency in Google, if you type about frequency in Google, most of the most of the frequency is mentioned about the atmosphere. Okay, like this. Okay, if you type in Google, the most of the result will go for atmosphere, meaning that the critical frequency is in favor of your friend in electrical school. Okay, antenna school, everything. They the critical frequency they understand differently than us. Okay, we are talking about critical frequency in spring. However, if you just type critical frequency in Google, most of the result will come out as related to atmosphere, antenna, and everything. Okay, that is not what we want. Okay, if you want to type in Google, you type critical frequency of spring, of helical spring. Okay, then this is the result that we want lah, kan? Okay, most of the no actual picture related to the critical frequency, uh, but as long as the spring is moving, okay, it has a frequency in it. Okay, as long as the spring is moving, it has frequency. No matter the spring, uh, the figure of spring like this or anything that bouncing, anything that bouncing can be called a spring. Okay, this is a spring, of course. Okay, but if you can see anywhere inside you, okay, whatever that is bouncing, uh, the principle is like a spring. Okay, so why is it critical for us to know about the critical frequency of a spring? Okay, you know about the resonance. Okay, resonant frequency. Okay, okay, this is the resonant frequency. If you type in Google, resonant frequency is the escalation of a system at its natural or unforced resonance. Resonance occurs when a system is able to store and easily transfer energy between different storage modes. such as kinetic energy or potential energy, as you will find with a simple pendulum. What does it mean in simple terms? That everything has a natural frequency, and even static things like your chair, your car, everything has its frequency. This is related to vibration subject lah. I try my best to explain in simple terms. Okay, when everything has a frequency, how about uh, there is another frequency that is uh, that is similar to that frequency. Okay, how about if there is another frequency outside source frequency that is similar to that frequency? When both are combined together, this wave, like say this wave and this wave happen to combine together, what happens is that it will become amplitude like this. It will become amplitude like this. Okay, so the pressure will become so high and that it may damage the structure lah. Yeah, it may damage the structure. If we're talking about spring, the spring will damage. If we're talking about uh, a chair, the chair will damage. Okay, I think most of you are aware of this. If you this type of people that have high pitch voice, they soprano lah, kan? Uh, especially when your mother kan shout at you kan, because you do something bad. Okay, your mother shout at you, or your wife shout at you, become pitching, and the voice is so high kan, it may break the glass kan, it may break the glass. Okay, this break glass with your voice. Okay, uh, glass shattering and everything. I'm sure you are aware of this. Okay, the glass may break because of what? Because of resonance, because of natural frequency. Okay, okay, the glass itself has a frequency, but when external force like people singing with high speech, high pitch, high voice, and uh, the vibration, the resonance coincide with the natural frequency of the glass will break. Kan? It happened. You can see many pictures in YouTube, many pictures we did even in cartoons, kan? Even in cartoon, Tom and Jerry cartoon, they have uh, this kind of video, kan? Okay, it is a true story. So, okay, so that happen lah. This is a natural, and talking about natural frequency. Okay, a natural frequency of voice. The application of the frequency is very is unlimited. Okay, so we want to avoid that to happen. We want to avoid that from happening. Okay, the same fact occur in helical spring, and it's called spring surge. Okay, what does it mean by spring surge? I think spring surge when the natural frequency of vibration of the spring coincide with frequency of external periodic force which act on it. Resonant occurs. This type of vibration motion is called surge of spring. Okay, uh, the spring may become surge. Okay, if one end of compression spring is held against a flat surface and other end is disturbed, a compression wave is created that travels back and forth from one end to the other like a swimming pool wave. Okay, try to find a picture related to it. cannot find. Okay. Okay, you see this image. Okay, this is what the textbook talking about lah. Okay, the textbook says that if one end of compression spring is held against a flat surface like this is a compression spring. Okay, this is a compression spring. All the spring that shape like this is a compression spring. Okay, one end is attached to the flat surface and one end is an open-ended. Okay, whenever you give the force to the spring, it will travel back and forth until the vibration dissipate, until it becomes stable again. Okay, becomes stable again. This is called the what does it mean by the textbook. Okay, spring manufacturers have taken slow motion movies of automatic ball spring surge. These pictures show a very violent surging, with the spring actually jumping out of contact from with the end plates. Okay, figure 10.4 is a photograph of failure caused by such spring. Okay, we see figure 10.4. The spring may break away. Okay, the spring may break away. This is what we want to avoid from it. Okay, so when helical springs are used in applications requiring rapid reciprocating motion, the designer must be certain that the physical dimensions of spring are not such to create natural vibratory frequency close to the frequency of applied force. Otherwise, the resonance may occur, resulting in damaging stress since the internal damping of spring is quite low. Okay, this is why when we want to consider spring in our design, uh, we must also consider all these kind of things. Okay, okay, because you imagine your car has a spring. Okay, the car your car has a spring, motorcycle has a spring. Yeah, then what happen if the spring, whenever you driving the car, riding the motorcycle, suddenly the wave from the wind, the wave from the other structure, maybe another external force coming, let's say when you are riding on the road, suddenly that road coincidentally become the natural frequency of your spring. What happen? Your spring may break away. Okay, if that spring break away, you will get damage and everything. You become hurt, accident and everything. That's why we must avoid natural the spring must avoid the critical frequency lah, kan? Okay, so the governing equation for translational vibration of spring is placed between two flat and parallel plates in wave equation. This is the wave equation. So you see derivation of u per x. So w per kg L power of 2, uh, the differentiation of U per dt lah. So, so K is the spring rate, come from the famous equation force equals to Kx, spring displacement F equals to Kx. Okay, so K is the spring rate, G is the acceleration of gravity, L is the length of spring between the plates. Okay, W is the weight of spring, X is the coordinate along length of spring, and U is the motion of any particle at distance x. Okay, distance x. So what is the x? What is U? I try my best to relate with this picture here. Okay, this picture here. Okay, you can see here. This is the spring. Okay, L is the word L is the height of the spring from bottom until the end. Okay, x is uh, x is any point here from zero until the bottom, until the upper surface is any point inside here, any point inside x. Okay, is any point. uh, and u, the word small u is the velocity of particle inside the spring. Let's say you put let's say you put a chewing gum. Let's say you put a chewing gum at any point, any coil of the spring. Okay, okay. Let's say you put a chewing gum at any point of at any coil of the spring, and then you make the spring move. Okay, the velocity of the chewing gum moving in the coil of the spring is u. Okay, in this u, this is what I, this is how you imagine u lah. Okay, okay. The solution to this equation is harmonic and depend on the physical properties as well as the end condition of spring. The harmonic natural frequencies for a spring plate between two flat and parallel plates in radian per second are W equals to M pi k square root of kg per capital W. So M equals to 1, 2, and 3 lah. So W is the harmonic frequency in radian per second, and M is the harmonic lah, first harmonic, second harmonic, and everything. I'm sure you have learned better in vibration subject. Okay, in vibration subject. So we are usually interested in frequency in cycles per second. So this W equals to 2 pi f. So we have the fundamental frequency in hertz equals to one half square root of kg per W. So assuming the spring end are always in contact with the plates. Okay, so Woodford and Smith show the natural the frequency is f equals to one a quarter 1/4 uh, square root of kg per W. Okay, okay. This is a two condition. Whenever the spring is always in contact with plate, I try to find a better picture. Okay, okay, baik. Baik. Okay, what does it mean by the spring is attached to plate like this? Okay, like this picture you see here, there are this one end is attached to a plate. This is called a plate lah. This one end is attached to the plate. Okay, one plate, two plate. Both end is attached to plate. Is attached to plates. Okay, then you have to use the equation F equal to half square root of kg per W. Okay, but when one end only it is attached to a plate like this, okay, only one end is attached to the plate and what other is free like this. Okay, then you have to use the equation, one a quarter of it, 1/4 kg W. Okay, uh, this is two condition lah. Okay, don't be confused. Okay, don't be confused. They also point out that equation 1025 apply when one end is against a flat plate and other end is driven with sine wave motion. Okay. Okay, for those who don't remember, this is a sine wave motion. Okay, the sinus wave, the sine equation. Okay, it has go up and down, up and down. This is a sine wave. Okay, this is a sine wave motion. Okay, meaning that it will constantly going up and down, going up and down until it becomes diminished. Uh, uh, so the weight of active part of helical spring is W equals to uh, AL lambda apa gamma forgot the name. Where gamma is the specific weight. Okay, equals to pi d equals to 2 over 4 pi d capital D and A uh, y ni gamma. So you have this equation lah. So d equals to 2 is the small the coil diameter, the wire diameter of the spring. D is the diameter of the spring, the biggest diameter of the spring, and A is I forgot, and A, but gamma is the specific weight over 4. This is the equation, the weight of the active part of the helical spring. Okay, so fundamental frequency should be greater than 20 15 to 20 times the frequency of force of motion of the spring in order to avoid resonance with harmonics. If frequency is not high enough, the spring should be redesigned to increase K or decrease W. K is spring constant, or W is the weight of the spring. Okay. Now, meaning that the critical frequency of the spring is related to the spring rate. Okay, the spring constant, or the weight of the spring. You have to decrease. Okay, you have to decrease the weight of the spring. Okay. Okay, meaning that you have to choose a smaller, a lighter spring lah, kan? Okay, lighter spring. Okay, okay, fatigue loading of helical compression spring. Okay, fatigue loading of helical compression spring. The spring are almost subject to fatigue loading. Okay, in many instances, the number of cycles required life may be small, say several thousands for a padlock spring or toggle switch, but the bulk spring of automotive engine must sustain millions of cycles of operation without failure, so it must be designed for infinite life. That's why uh, the spring design is very critical. Okay, because when we are talking about spring, you see the spring in your car. How many years you have buy that car? You have your family car, your father have buy a car, your grandfather also buy a car. The car is still moving until now. Okay, that car is still moving until now. Okay, uh, but we know from our subject there is a fatigue loading. Okay, meaning that at certain time the that material will become fatigue. Okay, any kind of material will become fatigue. Okay, but the spring does not become fatigue. Okay, because of what? Because of uh, uh, whenever design of the spring, it must be considered to become infinite life. Okay, it become finite life, meaning that you can use this forever. Okay, to improve fatigue strength of dynamically loaded spring, short pinning can be used. It can be increased the torsional fatigue strength by 30% or more. Short is about 1 per 64 inch. So spring coil diameter and wire pitch must allow for complete coverage of the spring surface. What is short pinning? I uh, I think you have heard it before in the in, in manufacturing process subject in year one. Okay, just to recall back what we have learned in first year about in manufacturing process. Okay, this is called short pinning. Okay, this is called short pinning. You see here, uh, uh, some sort of like, can I say ball bearing? Right? No, it's not. It's not directly is a ball bearing, but some small particle is short. Okay, is short into onto the surface. Okay, when that particle hit the surface, it will create a dimple. Okay, it will create a dimple. Okay, and when the dimple happen at the surface, it will create compression. Okay, it will create a plastic. It become plastic deformation on the surface, and also it become compression, and this will make the surface become stronger. This will make the surface become stronger. Okay, this is technology that have been used in aircraft. Okay, it has been used in aircraft to make the aircraft for fighter pilot to become more stronger. Okay, uh, this is called the short pinning. Okay. Okay. Short pinning is a cold work to impart compressive residual stress onto the surface of component will result in modified mechanical properties. The short pinning process is used to add strength and reduce the stress profile of the component. So whenever your component is not that strong, you just do the short pinning process. You short it with some sort of, that I say, a small ball bearing lah, kan? And then it's not a ball bearing, but the particle is like that lah, kan? Okay, and then when then the surface become stronger. Okay, so the best data on torsional endurance limit of spring are those reported by Zimmerly. He discovered that surprising fact that size, material, and tensile strength have no effect on the endurance limit. Okay, he tested on infinite life only. Okay, size, material, and tensile strength has no effect on endurance limit. Okay, or spring steel in size under 3.8 inch or 10 millimeter. Okay, we have already observed that endurance limits tend to level out at high tensile strength. But for the reason that is not clear, Zimmerly suggests that it may be caused with the original surface are alike, or because plastic flow during testing making them the same. Okay, so meaning that still ongoing research on this, on the spring. Okay, uh, uh, okay, unpinned spring were tested from a minimal torsional stress of 20 kpsi to maximum of 90 kpsi, and pin spring in range of 20 kpsi to 135 kpsi. Okay, so unpinned surface is called like this. Okay, the alternating stress the is 35 kpsi, and the mid range as M is for mid range. Okay, is 55 kpsi. Okay, for pin surface is 57 or 398 megapascal, or and for mid range strength is 77 kpsi or 534 megapascal. Okay, for example, given an unpinned surface, the ultimate strength is 200 to 101.5 kpsi, and Gerber ordinate intercept for shear is like this. So SE ni strength endurance strength is from its equation. So alternating strength SA is alternating strength Okay, SM is the mid-range strength and SU is the ultimate tensile strength. Okay, so you get for the equation, put all the equation, you get the 35.7, 37.5 kpsi. Okay, for those who forget what is the Goodman failure criterion, like this. Okay, if you can remember in the subject shaft, okay, in the subject shaft, also in the subject of previous subject before there is a Goodman criteria. It is more explained in this textbook in shaft topic, okay, about Goodman. Okay, there are Soderbergh line, Gerber line, Goodman line, the stress strain, SME elliptic line and everything. Okay, what it represent? It present the material failure, where the point that material become failure. Okay, that if we result in the on a straight line, and then what you can do is you project line. Okay, you just project the line and you intercept it using the what is skill that you have in during mathematics class. If you remember the equation y equals to mx plus c, okay, then the teacher asks you to project the line like this, okay, like this. You project the line, then you get the value. You just have one value. Let's say the mid range value, and then you project to the intercept to the line, and then you get the alternating stress value. Okay, this is what the mean by intercept lah. Okay. Extended study available in literature regarding torsional fatigue found that for polished, notch-free cylindrical specimens subject to torsional shear stress, the maximum alternating stress may be imposed without causing failure is constant and independent of the mean stress in cycle, provided that the maximum stress range does not equal or exceed the torsional yield strength of the metal. Okay. If notches and abrupt section changes, this consistency is not found. Spring are free of notches and surfaces are very smooth. The failure criterion is known as science failure criterion in torsional fatigue. What does this sentence mean? What does this sentence mean? First, first, uh, you okay. Let me let you first you must know what is a notch mean. Okay, what is a notch mean? If you type the word notch, the word notch is used in also in medicine. Okay, it's also in use in medical. Okay, but in engineering, the notch mean like this. In Malay, it's called takek ah. If in bahasa Melayu, it's called takek. Okay, there is a space that is a notch. This happen in the failure will happen at the notch. Okay, so that is why the failure always begin at a notch. Okay, because uh, like this. Okay, like this picture. Okay, this picture, the triangular surface here. Okay, okay. Uh, if this structure will become failure, it will fail at notch first rather than at somewhere else. Okay, okay. That is why we have to avoid notches in spring. Okay, spring must have notch free, polished surface notch spring, there are no notch on the surface of a spring. Okay, then the alternating stress, okay, alternating stress will be imposed without failure lah. What does it mean by alternating stress? Okay, you see here, because spring uh, always move up and down, you know, kan? Always move up and down. Okay, okay. There's it will become an alternate process. Okay, if we translate it into the graph, it will become a sinus graph. Okay, the sine graph like this. It will resemble like this. Okay, this is the mid-range graph represented by SM. Okay, the word M is in the mid-range lah. This is the stress amplitude. We become maximum and minimum like that. Okay, so whenever you want to buy a spring, and then you physically you can see with your eye that spring is have damage on the spring of the surface, you you don't buy that spring. Okay, you go to the shop, you want to buy a spring, and by your eye physically you see that spring have notches. Don't buy that spring. Okay, the spring will fail. Okay, the failure criterion is known as sinus failure criterion in torsional fatigue. Okay, so in constructing a certain failure criteria, the on the designer's torsional fatigue diagram, the torsional modulus of rupture SU is needed. We shall continue to apply equation 6.54 in page 335 in this textbook. Is as ultimate uh, torsional modulus of rupture is 0.67 ultimate strength. In the case of shaft and many other machine members, fatigue loading of the in the form of completely reverse stress is quite ordinary. Helical springs, on the other hand, are never used as both compression and extension spring. In fact, they are usually assembled with preload, so that working load is additional. Thus, the stress time diagram in figure 6.3 to 3D express the usual condition for helical spring. The worst condition will occur when there is no preload, where torsional stress is zero. Okay, what does it mean by preload? Okay, what does it mean by spring preload? It is best represented by this image. Okay, it is best represented by this image. You see here, is the left one is free length. No load is given on the spring, and then this is the preload. You put a weight on the spring, it become some deflection. Okay, this is called the preload. You imagine your car, your motorcycle, everything that has a spring. Of course, the spring is attached to plates. Okay, when the spring both ends is attached to a plate, it is called a preload. What okay, it is called a preload. Okay, this end have attached to plate, this end has attached to a plate, both is called preload. Okay, so okay, so we define FA is alternating force and FM is a mid-range force. Okay, if maximum to minimum, so over 2, so FM mid-range. Okay, Fx plus F min over 2. So okay, again I take this picture as to make you understand. uh, uh, the concept is the same, you know. This picture uses the stress, but it also have the if you graph is replaced with the force, this is the alternating force. You have the force amplitude maximum, force minimum. This graph for the stress maximum, stress minimum, and this at the middle line is the mid range, force, the mid range stress. It's the same concept as FA and FM. It's the same concept. Okay, and where the subscript have the same meaning as those in 6223D when applied to axial spring rate, axial spring force F, and the axial stress amplitude is shear stress A is stress amplitude is KB. KB is burst fracture factor. Okay, NA at FA D per pi D power of 3. You can see the better explanation on burst fracture factor in last week, last Tuesday class. There is in upper chapter of this subject. It's called burst fracture factor, where we have the two conditions, whether you want to use burst factor factor or you want to use called wall factor, because the difference only 1% difference. So the textbook use KB lah, burst factor factor. Okay. uh, obtained from figure equation 10.5 and correct for both direct shear and curvature effect as noted in section 10.2. The wall factor can be used instead if desired. The mid-range shear stress is given by equation Tm equals to Kb 8 mm d over pi d equals to 3. Okay, this is the example. It's already 8:50. Okay, it's already 8:50. I cannot cover all the example, but you have to uh, go through this example. At least you have some understanding of this lah. Okay. So we use the three approach to estimate the fatigue factor of safety in example 10.4. The result in order to smallest to largest, where 1.18 size Gerber and 123 Goodman. Okay, this is refer to the Goodman failure criterion, Gerber failure criterion, and Goodman failure criterion. You can see better explanation in shaft subject. Okay, although the result are very close to another, using the Bali data which have the sign criteria which is always the most conservative, and Goodman the least. Okay, we perform the fatigue analysis using strength properties as we done in chapter 6. Different result will be obtained. Here the Goodman criteria will be more conservative than Gerber criteria. Be prepared to see the designers or design software using any of these technique. This is why we cover them. Which criteria is correct? Remember, we are performing estimate and not only testing. We reveal the two statistically, meaning that if you use whenever you use the sinus, Gerber, and Goodman result, it will have uh, uh, many results, and the results are different with each other. Okay, the result are different with each other. Okay, and which result are correct? Okay, which result are correct? The first thing, the correct one is what do you want? Okay, the first thing is the correct one is what do you want? What application that you want? For say example, you want to design the spring of a car. What type of car? The car that you use to go to the market, or car you use to racing, or car you use uh, to go into outdoor. Okay, this type of car have different criteria of the spring. Okay, the different criteria of the spring. Okay, and then you have the criteria. Okay, and then when you use this criteria, you have, when you use this movement, you have this result. And then what in this result you have to test. Okay, and when you test, you have get the actual result, and then uh, you choose what the spring that you want. Okay, always do the testing lah. Okay, I think that's all for this subject. Okay, in the next Tuesday class we will go into the helical compression spring design for fatigue loading. Okay, so that's all for my class today. Okay. How many people are coming in this class? 38. Only 61 people. Oh, half, only half of the class lah. Setengah lah pada kelas. Oh, betul tu. Okay. I forgot to do that quiz. But suppose I better to do quiz. If I see the attendance like this, I do a sport quiz. Okay. Next week I might consider to do pop quiz. Kan? To, if I see this attendance like this. Okay. So, I think that's all for today class. Do you have a question? Have a question?
No, sir.
No. Always Iqbal answer. Okay, always Iqbal answer. Good, good person lah Iqbal. Uh, uh, anybody left? Oi, Syarif Osna dah left lah. Cepat deh. Okay, so